you get an error.
Sorry.
So, yeah.
Hello.
Yes.
Can you think like for one image, how many mask is used?
Okay, very good question. Actually, one mask is used, but this particular data set has it came with several masks. But I'll get to the code. In the code, we actually join all these masks together to form one mask. Let me just briefly show us um, here. This is so inputs. I'm going to show us now how a mask looks like. So this is the mask for this first. This is how the code works. Now let me show you the mask. Aha. So can we say so it joins all this, the code joins all these masks together. The data set is a bit complex. Most data sets just have one mask for the image, but I had to use a code to join all these masks to just form one mask. Do you understand? And I'll show us later on. Is that clear? So we can see if you compare the two images together, this one and this one, we can see the mask of this one is here, this mask for this one, and like that, and so on and so forth. So this data set was a bit complex. It scattered the masks to several. Um, so the mask is usually supposed to be one, usually, especially in image segmentation tasks. Um, so thank you for that question. I hope you understand to a degree. I'll still explain further. So I'm just pressing forward for time. Sorry. Okay. Can we still hear me? Someone's mic is unmuted. Thank you. So now we're going to move on to the encoder and the decoder of the unit. It's important to understand all these things so that we can easily know where our code is missing it or where the errors are coming from. So after we have our image and masks, we write a ton of code to pass each image through the encoder or and the skip pathways and the decoder of the nested units. So basically, the code we'll be writing will pass this image and the other thousands of bits in the data sets through the encoder. This place, which we call the backbone, is also the encoder. Is the encoder. This place here is the encoder, and this going upwards is the decoder. So the image will pass through this route. It's also passed through this route too before it gets to the final um, convolutional block. So back to the. It's important to note that this unit structure that we see on the right is very similar to this one. The only difference are the skip layers. Okay. These lines, these layers that you see, the convolutional layers and the padding and the pooling layer rather, all these three that you see, one, two, three, they're actually in this circle. One, two, three in this circle, and so on and so forth. So it's really the same thing, but with skip layers added to it. And of course, we do deep supervision, which is represented by these red lines. We'll go to that shortly. I'm just explaining, giving a shallow explanation of everything. Okay, so I just designed this diagram. It might look crazy, but just designed it to try to understand why my actually this particular layer that was getting an error. It was expecting a particular value, that's 64 times 64, but it was getting something else. So I drew this graph to understand how the image sizes change as it passes through the entire unit plus plus model before it comes out from, before the predicted output comes out. So let's say the image you're passing in is 128 by 128. When you pass it into the first layer, it's now I zoomed into this to show what is in a typical level of the unit plus plus. So in this circle x00, you would typically see two 3x3 convolutional layers, two 3x3 convolutional layers, and in between them you usually see batch normalization and ReLU function, and then the last layer would be the pulling or downsampling layer, now which is a 2x2 layer. And what that does is that this image that was 128 by 128, when it's sent to the next x10, it's sent as 64 by 64. It halves its size. It becomes half its size. Although the number of channels double, but the image size becomes half its size, 32, 16, 8. And we also see how it works with this little, I'll call them transpositions here. So this, if you check this entire line, you notice everything here is receiving 64. Everything here is supposed to receive size 64. Everything here is supposed to receive size 32 by 32. Everything here size 16 by 16, and so on. So when the image passes through the unit or the unit plus plus and gets here, a transposition occurs. So when it passes through the encoder, when it gets to the end, it's an operation called deconvolution or transposition or interpolation takes place, which would make the image, which will make the entire model or architecture to start learning the more special details of the image. So when it passes through the encoder, all the model or the architecture learns is the what, that's the WH80, the contents of the image, but it cannot yet fix it cannot yet it cannot yet tell where the contents are located, right? So you need the decoder to do that. You perform an upsampling operation or transposition or deconvolution. Okay, so that's how the unit works. And at the end of the day, what reaches here is a predicted representation of the input. And that is now compared to the masks. Where's that mask again? That is now compared to this to calculate the loss function, meaning how far away is the predicted value from this original target variable. I'm sure we must be familiar with target variables already. I'm just calling it a target variable for explainability. I'm not sure that's what they actually really call it. It's a mask. It's used to just tell the model, okay, you've predicted something, but you have to align with this. So the model sees this and it adjusts itself. So loss functions are calculated, accuracy. and all that are calculated with this original image, which was passed into the model in form of the image, not as the mask in form of the image, but it comes out as a mask. The predicted value of the units plus plus model is a mask, which is now compared with this image, which is the original image. Okay, so we can go through I wrote some other things, but they are not so important. We can go through the repository to understand them better. Now let's go to the code, right? This is the part we're waiting for. So like I said earlier, I did my code in GitHub Codespaces because it was bringing up all sorts of errors on my laptop. And then again, the libraries that I needed to install, they were just conflicting. One library will not uninstall properly. Then we have two different versions of that library, and it was really messy. I had to manually delete some library versions and all that. So the best way to do it, I've made it actually simple by just providing this requirements.py contains all the necessary libraries that you need to, as at now, that's February. What's the date? It's February 2025 that you need to run this model on a CPU and probably on a GPU too. Okay, so if you're having issues with the libraries and conflicting and all that, that's completely normal. Just run that requirements.py. It contains all the versions that you need, and they don't clash. They don't. They are all compatible with each other. Okay, so now let's go to the code. All right. So the first thing can we all see the code? Let me just get a response. Just a response. We can see the code, right? Okay. Thank you very much. Okay. So I have here about 8 Python scripts, which I ran in order to make the model work. You could just run everything in a Jupyter notebook, like I tried doing at first, but that also brought a lot of errors. I did some research and I found out that you can't run all the codes you need to perform image segmentation with units. You can't run all of them on a Jupyter notebook because a lot of times it brings up parsing issues. It has a lot of Jupyter notebook isn't so efficient in doing those kind of things. So the best thing to use is your command line or your terminal. So that's what I used. I used my terminal. Don't mind all this. I was trying to do something. So, but let's explore each file. So we have like 8 files. I won't go into the in-depth explanation of what these codes are doing, but I'll just give a shallow explanation. So the first file is the first script rather that you would run is the preprocessing script. Now you need to preprocess your image data depending on the data set you are using. And of course, like I said, that data set must have images and their masks. So I've already shown you, I'll still show you later on how, or you can just read, I'll explain it. Okay, so, but let me go straight to this. So this preprocessing script, what it does is that it's harnesses this data set, the original data set to my left window, this one, which I downloaded from Cargo, and it reshapes it into this.